Welcome. In this video, we're going to talk about what determines if an acid or base is considered to be strong or weak. Reactions of acids and bases depend on the fact that they dissociate or ionize in water and release either H plus or OH minus ions. Acids also release an anion and bases a cation, but those don't affect the pH or the acid-base nature of the solution. So we're not going to worry about those ions at this point. The extent or how much an acid or base dissociates determines the strength of the acid or the base. An acid or base that dissociates a lot is considered a strong acid and is said to go to completion or nearly completion, and the equilibrium lies far right. So it has very strong acidic qualities or basic qualities. Weak acids or bases only partially dissociate and have an equilibrium position far left with a very low Kc, or we call the equilibrium constant Ka or Kb, and only show very weak acidic tendencies. So as I said, strong acids and bases are considered to exist in solution completely as ions with an equilibrium far right. And this means a couple things. It means the conjugate acid or base is very weak. So here's my conjugate acid, my conjugate base. It means very little of this will go back to form HA or go back to form BOH. And that's why a single arrow is used and is considered to be just a forward reaction with no Ka or Kb being calculated. Weak acids and bases, though only partially ionized and have an equilibrium far to the left, so usually less than 10 to the minus third. So we use the double arrow because it definitely is reversible. And in fact, very little goes to the right. And the relative strength then is compared by comparing the equilibrium constants, which again we call Ka and Kb, depending upon whether it's an acid or base we're talking about. So weak acids or bases exist almost entirely in their undissociated form. So HA mostly stays HA with a little bit becoming H plus and A minus. So now this means the conjugate acid or base is very strong. This conjugate acid conjugate base, I should say, very much recombines with the H plus, forming almost entirely HA or keeping HA in the solution. So how do you know if an acid or base is strong or weak? Well, it's completely a property dependent on its bonding, and ironically, the strong acids or bases have a weaker bond here, so they fall apart more readily, and the weak acids or bases have a stronger bond holding them together. Okay, and then just a quick word about concentration. Strength and concentration are not the same thing, although we often use the words interchangeably when we talk about strong coffee or weak coffee. But with acids and bases, strength is measured or expressed with the Ka or Kb, and it lets you know how completely the acid or base dissociates. Concentration is the amount of water added to the solution. So it's possible for a weak acid to have a strong concentration or high concentration. We'd say it's concentrated. It's also possible for a strong base to be very dilute or have a very low concentration. So be careful about those two terms. Weak acids and bases are actually far more common than strong acids or bases. And I mentioned earlier, you should be able to recognize strong acids as just being HCl, HNO3, and H2SO4. The strong bases only include barium hydroxide, lithium hydroxide, sodium hydroxide, and potassium hydroxide. And I remember that with the word BALINK. Those are the four metals that form strong bases. Everything else is a weak acid or base. The most common ones that IB will use as their examples is for the bases, they'll use derivatives of NH3, known as amines, and they're weak bases that pick up a hydrogen and leave behind an OH minus. They take a hydrogen from water and leave behind the OH minus, making them a weak base. And then the organic acids end in COOH, that's a carboxylic acid group. And the hydrogen from the end of that, from the OH group, breaks off and dissociates in water. Those are the weak acids you'll be expected to recognize. So how do you distinguish or test for strong or weak acid? Well, when you compare equal volumes of a strong or weak acid or base, the strong one's going to have more H plus or more OH fall off of it than the weak one will. So that means we can look at different properties that rely on the H plus or OH minus concentration in that solution. So one way to do it is electroconductivity. You can use a conductivity meter, and your strong acid or strong base will be more conductive than a weak one. But that will only tell you if it's strong or weak. It won't tell you if it's an acid or a base. The rate of reaction is another one. Rate's going to be dependent on concentration. So strong acids will release more H plus concentration than a weak one will. So you'll have a faster reaction rate, such as more gas or a bigger temperature change being produced. And then pH, strong acids obviously will have a lower pH, while strong bases will have a higher pH. And you can use the pH meter or universal indicator to measure that. Only pH will actually tell you if it's an acid or base. 1 or 2, depending upon what you're reacting it with, may or may not indicate if it's an acid or a base. Like if you're doing a neutralization, it'll simply let you know it's being neutralized. So arrange these compounds in order of increasing pH. Now, this is a favorite question for IB. Remember, increasing pH actually means you're going from most acidic, or your strongest acid, and then to your strongest base. So you're going to go from acids to base, and from strong to weak, weak to strong is really how we want to arrange them here. So the strongest acid out of this group is H2SO4. That would have the lowest pH. My weak acid in this group is CHCOOH. That's my clue. It's a weak acid. My weak base is CH3NH2. It's got that amine group or a variation of it. So that's going to be a weak base. And then my strong base will have the highest pH, and that's NaOH. Which acid and base from number 1 would form the strongest conjugate acid or base? So a strong conjugate acid or base means it will not, it will easily release and go back to the acid or base it formed from. So the strongest acid or base falls apart. So both CH3NH, that would have the strongest conjugate acid, and COOH would have the strongest conjugate base.